Hello everyone. So this is the example that I showed you earlier. So let's read the question together. A 10-meter wide rectangular channel carries a discharge of 30 cubic meter per second. So this is a rectangular channel. The discharge is So this is a rectangular channel, and the discharge is 30 cubic meter per second. Okay, and the width of the channel is 10 meter. Okay. So the gate opening is 0.5 meter. The slope of the channel is 0.005 meter per meter. So the slope of the channel is SO. So the value is 0.005. And so we are given here the information on the gate opening. So if we have a flow like this, bottom slope of 0.005, and we have a gate here. So the opening of the gate is 0.5 meter. So this is the distance from the gate to the bottom of the channel. Okay, the upstream and downstream boundary conditions are normal depth. The upstream and downstream boundary condition. So we have upstream and we have also downstream somewhere here. So this is normal depth, and here it is also said in the question, it has normal depth. Okay, assuming the system has reached steady state condition, okay, first determine the normal depth. So we have to determine first the normal depth, determine the energy associated with normal depth. So this is E naught. Okay, determine the classification, either state, mild, or critical for this reach. Okay, and D, determine the depth and specific energy immediately upstream of the sluice gate. Okay, depth and specific energy immediately upstream of the sluice gate. So this means it has to be, we have to find the depth here and the energy immediately upstream of the sluice gate, something like here. Okay, if the hydraulic, if there is a hydraulic jump, determine the depth on both sides of the jump. Okay, so imagine if we have imagine if we have a hydraulic jump. Okay, determine the both sides of jump. Okay, so for this question, it means we have to find y conjugate. Okay, and F. Okay, this is question for F. Sketch any flow profiles that exist. So we have to sketch the flow profile. And finally, question G. On an EY diagram, plot all the relevant profiles and energy depth combinations for this problem. Show that the system analyzed amounts to an energy conserving loop. Okay. So actually this example is given from the textbook. You can also follow the step-by-step solution from the textbook, but I will explain also to you in this video. Okay. Okay, first of all, okay, let's draw again. Okay, so B is given as 10 meter. B is the width of the rectangular channel. Okay, and okay, So the Q is 30 cubic meter per second. So since it is a rectangular channel, so we can find Q. So Q is equals to 30 divided by 10. So it's divided by the width of the channel. So we have 3 cubic meter, no, 3 square meter per second. Okay. So since in this case n is given as 0.003, okay, sorry, not 0.003 but only 0.03, okay, and the slope of the channel is equals to 0.005. Okay, let's find the first question, the answer for the first question. So the question wants us to find y 0, which is normal depth. So in this case, the book, okay, since Manning equation is given, so you can use Manning's equation to find the answer for this question. So it's r to the power of 3 s. Okay. But unfortunately, since not unfortunate, okay, you have tried before that if you want to find normal depth, we have to use trial method, right? Okay, you can find the answer using trial method, but the textbook also suggests that we use the goal-seek function, which you can find in the Excel goal-seek function. Okay, I will make a special video about this goal-seek function in the Excel, from the Excel. But at the moment, we just have the answer, we just take the answer of normal depth from the textbook. Okay. Okay, what I mean is that we put these things away for a while. Let's just finish the exercise, the example. Okay, I will come back to you about this topic later in my video. So the answer from the textbook is given as y normal depth is equals to 1.26 meters. Okay. Okay. Now in question B, you have to find the energy related to normal depth. So the energy related to normal depth is using this equation that you have used before. This is energy equation. To y to g. I already showed you how to derive this. Okay, so you fill in all the information. 1.26 plus q is 3 to the power of 2, divide by 2, multiply by 9.81, and multiply by 1.26 to the power of 2. So the answer is 1.55 meter. Okay, good. Okay, so this is straightforward. And let's find the answer for question C. So question C wants us to classify the reach. So when we want to classify the reach, either whether the reach is step or mild or critical, then you have to know the rules. This for these rules, if you remember, we have to compare y normal with y critical, right? So if you know y critical, then you can make the comparison. So in this case, we don't know y critical. The critical depth is not known, so we have to find the critical depth first. So yc is equals to q to the power of 2 divided by g, and for this one, this is to the power of 1/3. So again, just put everything because we know all the information, so we can solve this question. Okay, 1/3, and the answer is 0.97 meter. So since y0 is 1.26 and yc is 0.97, so you know that y0 is larger than yc, critical depth. So from the book, from the figure 5.3 that I showed you from my previous video, this is equals to mile reach. But we don't know yet whether it is M1, M2 or M3. So at the moment you just put MX. Okay, so this is mile reach. Okay. So then we go to the next question. This is about the sluice gate. Okay. I will see you in the next video to answer question D regarding to the sluice gate. Okay, see you later in part 2.